right, let's look at some application problems for the GCD and the LCM. True-false problems always find a little bit tricky. So the GCD of two numbers, we're going to call them A and B is equal to 1. So in this if-then statement, that's true. The GCD of these two numbers is 1, which means they don't have any divisors in common. Well, we want to see if it's true or false if the LCM of those two numbers is the first number, A. And I'm just going to kind of give an example so I can wrap my head around that. So I'm going to think of two numbers that don't have any divisors in common besides 1, because 1 divides everything. So I'm going to go with kind of easy or silly numbers. So 2 and 3. So 2 and 3, if I were to list out their divisors, the divisors of 2 are 1 and 2, and the divisors of 3 are 1 and 3. So the only number they have in common is 1. So this part I have true. I want to see what happens to the LCM. So let's see what the LCM of 2 and 3 is, the least common multiple. So the multiples of 2 are 2, 4, 6, 8, etc. The multiples of 3 are 3, 6. Oh, we already got it. The least common multiple is 6. My statement wanted to say the LCM of these two numbers was A. And in this case, that would have been 2. My answer isn't 2, so it's false. So I just found a time that it's not true. So therefore, it's never true. Like, the answer is false. Let's try another one. The GCD of A and B is equal to 1. Okay. So we know that that could be my two numbers. The GCD of 2 and 3 is equal to 1. We found that up there. A and B cannot both be even. Okay, they're not both even, so that's true. Yep. Let me see. Let's try another one. Let's find the GCD. Let's find some other ones where 1 isn't even. So maybe like 4 and 9. They're equal to 1. Yeah, that's true. Let's see what happens when they both are even. So 2 even numbers. The greatest common divisor of 2 and 4 is 2, because 2 divides both of them. So when they are both even, the GCD isn't 1. The GCD is 2. If you have 2 even numbers, 2 is always going to divide them. It doesn't matter what even numbers you think about. Think about any 2 even numbers. We know at least 2 divides them because they're even. We've done those factor trees. Whenever we have an even number, we can divide by 2. So the only way to have a GCD of 1 is for one of the numbers not to be even. They both can't be even. So this is a true statement. If they have no numbers in common, then they both can't be even. Like one of them at least has to be an odd number, if not both of them. If you need to pause, think about that, and rewatch it, you're not alone. Feel free to do that. All right, let's look at some of these word problems and leave those true false behind. We've got 2 people walking on a track, walking laps. They're going to start at the same time and place and go in the same direction. But one person is walking faster than the other person. And we want to know how long it will take them to be in the starting place at the same time. Now, you can use any method for this. You basically just have to determine, am I looking for a multiple or a divisor? So if you think about walking laps, if you're timing yourself, your time gets bigger. Every time you walk, let's say you're Jane, every time you walk, it's 15 more minutes. So it's 15 minutes, the next lap is 30 minutes, the next lap is 45. So we're getting larger. So that's how I know that I'm going to be looking for a multiple. Because I'm thinking about as I go through, every lap adds more and more. You can use whichever method you want to use. Most people prefer the listing method, but if you're a prime factorization person, there's nothing wrong with that. Multiples, you do kind of just have to keep going till you feel like you can stop. So I did 12 times 1, 12 times 2, 12 times 3, 12 times 4, 12 times 5. I usually go out at least 5. Multiples of 15. 15 times 1, 15 times 2, 15 times 3, 15 times 4. Oh, there I am. 60. So if they walk at that steady pace after 60 minutes or 1 hour, they'll be at the same place again. All right, next one. 2 bands are to combine to march in a parade. There's a 24-member band and a 30-member band, but they want to combine so they have the same number of like columns of people walking. So there's not like one band that looks wider than the other band. So if we're taking a band and we are putting it into columns, that means we are dividing it. So we're making it smaller. Doesn't matter. Sometimes this problem comes as rows of trees, but if you have this big group and you're putting them into rows or columns, you're making it smaller. So that's going to be the GCD. We are dividing it. So why don't you pause the video, use whatever method you want to see if you can find the GCD of these 2 bands. All right, let's see how you did. I did the listing method again, just because a lot of times people prefer that method. You don't have to. You can do the prime factorization method, and it's going to work out just as well. There are a lot of divisors of 24, so 1 divides it, 2. Oh, sometimes it helps so you don't forget some of the numbers. If when you divide 1, you go ahead and put the other factor divisor down there. 2 would be 12, 3 times 8, and 4 times 6. That's a method so you don't forget one if you have a lot. These are finite sets. They're not infinite like the multiples. They do stop. Again, it'd be 1 times 30, 2 times 15, 3 times 10, and 5 times 6. You don't have to put them in order. That's the good thing about sets, is you can have them in whatever order you want to. You do have to find the largest number that's in both of these, and that would be 6. I know there are other numbers. They both have a 1, a 2, a 3, and a 6, but since it's the greatest common divisor, we want the one with the largest number.